Hello students, welcome to the module on trigonometry. In this video, we'll see how to plot the graph of y equals sine x. So we'll consider the wrapping function, w of theta is the point x, y. And we know that if this is the case, then y is equal to the sine of theta. And so if we plot the unit circle, here's the x-axis, here's the y-axis. And we draw the line that is tangent to the unit circle at the point 1, 0. That's the point 1, 0. This is my theta axis. And if we wrap any interval from 0 to theta around the unit circle, we get to this point, w of theta. Now we recall some of the common values of w of theta. We recall that w of pi over 6 would correspond to that point on the unit circle, and that would be the square root of 3 over 2, 1/2. W of pi over 4 was the square root of 2 over 2, the square root of 2 over 2. W of pi over 3 was 1/2 root 3 over 2. And then w of pi over 2 was at this point over here. That was a quarter of the way around the unit circle, and that's all the way up at the point 0, 1. And if we keep track of the y values go from 1/2 to root 2 over 2 to root 3 over 2. Now, of course, 1 is also the same thing as the square root of 1. So I have the square root of 1, the square root of 2, the square root of 3. And I can think of 1, I can write this in sort of a strange way as 0, and then the square root of 4 over 2, because the square root of 4 is 2, and 2 divided by 2 is 1. So I have 1, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2 in the first quadrant. So if we're to plot the graph of y equals sine theta, what we can do is we have the y-axis, we have the theta axis, and we can plug in some initial points. The sine of 0 is equal to 0. The sine of pi over 6 is equal to 1/2. The sine of pi over 4 is equal to root 2 over 2. The sine of pi over 3 is root 3 over 2. And the sine of pi over 2 is equal to 1. And so if we plot all these points and they're progressively increasing, we see the sine bends up like this. Now, as we go into the next quadrant, the sine now is going to follow the same trajectory except going down. So we can go all the way up to pi, and then I'll have the exact same behavior going down. And once we get down to the negative values, we see the exact same behavior happens except opposite. So if I go from 0 to the left, I have the same values but the opposite sign. So the graph will be symmetric over this axis. So this will be the point negative pi. This point over here will be the point negative pi over 2. This will correspond to a value of negative 1. This maximum over here will correspond to a maximum value of 1 that occurs at theta equals pi over 2. Notice now that from negative pi to pi, we have an interval of length 2 pi. The periodicity of sine implies that the sine of theta plus 2 pi is equal to the sine of theta. So once we've graphed the sine of theta over an interval of length 2 pi, to plot the sine on further intervals, we just pick this graph up and slide it over either to the left or to the right. So to plot the rest of the graph, pick up this graph and move it to the left and right infinitely many times. That's a fancy way of saying that if you want to graph this graph, say for example from pi to 3 pi, from pi to 3 pi, that's another interval of length 2 pi, we would simply take this graph over here and slide it over and paste it right next to this graph. If I wanted to graph from negative 3 pi to negative pi, I would take this graph over here and shift it over and plot it right over there. So I will have this same version of the graph, the same exact shape, that's pasted over and over and over again as we go from pi all the way to infinity and negative pi all the way to negative infinity. Thank you very much.